All right, this is our last lesson for the day, talking about a certain kind of graph called a histogram. You might have seen these in middle school or high school. They're a pretty common way that we can visualize or represent data. So a histogram is a graph that consists of contiguous or adjoining boxes and can show you the shape of the data. So where is most of the data located, the center, and the spread of the data. The horizontal axis is labeled with what the data represents, and the vertical axis is labeled with either the frequency or the relative frequency. So in our first example, we have a histogram given to us. We have the values labeled here on the horizontal axis. In this case, they have half values, so like 3.5, 6.5. And then on the vertical axis, we have frequency. How many times do each of these values occur? And I want to know how many values in this data set are between 4.5 and 6.5. So what I care about are the data between 4.5 and 6.5. So I see that between 4.5 and 5.5, the height of this box tells me how many times these values occur. So I see that this box occurs, the data in this box occurs 7 times. I see that the data in the next box between 5.5 and 6.5 occurs 4 times. So I have total 11 pieces of data between 4.5 and 6.5. So again, our height here of each box represents the frequency, or sometimes the relative frequency, of that particular value. And then we have another example. Given the following frequency table for the set of data, which histogram accurately summarizes the data? So we have values 6, 7, 8, 9, 10, and 11, and then we have all of these frequencies as well. So I want the value 6 to have frequency 6, but it appears that none of my values have 6 labeled on the graph. In fact, this one right here doesn't have anything close to 6, so we can toss this one out right away. In fact, C does not have 6 either, right? It starts at 7.5, so it's not going to account for that data. So we are just between B and D now. So I want 6 to occur 6 times. If I look at B, I see that between 5.5 and 6.5, which is where 6 is, I do have 6. I want the value 7 to have a frequency of 3. Well, 7 is between 6.5 and 7.5, and that has a frequency of 3. So we're good there. I want the value 8 to have frequency 5. 8 is between 7.5 and 8.5, and I have the frequency of 5, so we're good there. I want the value 9 to have frequency 6. 9 is right here between 8.5 and 9.5, and it does have frequency 6. We want 10 to have frequency 4. We're good there. And finally, we want 11 to have frequency 9. So we're good there. So B is our answer. It might be a little bit confusing since we don't have the values 6, 7, 8, 9, 10, 11 on our graph, but actually that's a good thing, because if I had, 6 here, 7 here, 8 here, 9 here, then the value 6 isn't between 6 or 7, right? It is 6. So in fact, when we have histograms, we do want the data that we are representing to not be like on these edge points here, because that makes it more challenging to accurately represent the data, right? Because this between 5.5 and 6.5 is representing all of the data between 5.5 and 6.5. So 6 fits very easily in there. But if I had 6 and 7 as my 2 edge points, then where would I put 6? Where would I put 7? We would have to decide that. What's wrong with D here? I see if I were to compare, actually all of them have the same shape, right? They all have the same exact shape. But D starts at 3.5, which we don't have data for, and it ends at 9.5, and we have data past 9.5. So that is what's wrong with D. So B is our answer. So this is a pretty short lesson on histograms, but I think most of us have seen these before. Bye.